So we'll be joining shortly within 5 to 10 minutes. Okay. Hello. Hello everyone, welcome you all to the webinar. So we will be starting the webinar within 5 minutes, okay?
Hello.
Hello?
Yeah, hi Vikas, can you hear me?
Yes, sir, you're audible.
Yeah. Just give me a
Okay,
minute. I
hello
will.
everyone. Yeah, yeah.
Hello.
Yes, sir.
Yeah. Can we start, Vikas?
Yes, sir, just a minute.
Hmm.
Hello everyone. On behalf of ISIEINDIA, I would like to welcome you all to the webinar on EV powertrain architecture and modeling using Simulink. And I would like to welcome our today's speaker for the webinar as well. Now I would like to request you, sir, to address our audience. Over to you, sir.
Yeah. Thank you, Vikas. So myself, Ganesh, I was working in EV industry from the last 6 years. So I was working in the motor development and all things. So now I'm going to share you the screen. Just give me a minute. Everyone can see my screen, right?
Yes, sir, it is visible.
Yeah. So, good evening, everyone. So, today we are going to discuss regarding EV powertrain and architecture modeling using Simulink. So, nowadays we can see the EV industry was going very vast. Like we have wherever we go, there are lot many changes, drastic changes in electric vehicles. Like we are reducing the IC engines and coming towards electric vehicles. But the only common thing where we are changing is here we have IC engines, so just some companies they are just changing the powertrain and they are keeping the vehicle the same as usual. Suppose if you go for some vehicles like Tata Nexon, so what they have done, like we have the Tata Nexon, but they have just changed the powertrain IC engine to electric vehicle. So you can see so many are like retrofitting the electric vehicles. So the only thing is they are changing their drivetrain system. So nowadays, so many like industries are looking the people who are more in the EV domain and who are more familiar in EV powertrain, and like some courses related to power electronics and modeling using Simulink. These kind of the things are very important when you go for the when you are looking for the job opportunities as an initial career. So let's come to today's our session. So we are going to discuss regarding EV powertrain architecture. So how the replacement of engine to motor. So what are the things when we are going for the powertrain replacement, like when we came to the motor, what are the things are being added in the powertrain, and what are the things in the IC engine, what is the power source, how the vehicle architecture system will be working. So that one we are going to learn. And vehicle performance characteristics, like what is your speed, torque, and how you are going to calculate. So mathematical modeling of electric vehicles. So mathematical modeling is nothing but like what is your rolling resistance, aerodynamic resistance. So these are all the things, and how you will calculate your initial velocity and final velocity. So here I have taken a small example, and we can show in the demo. Like we are be doing in the a small Simulink. So we can see the demo and electric powertrain modeling using Simulink. And a career in EV industry. As I said in the starting, we have lot many opportunities. There are lot many opportunities in careers in EV domain. So that one we are going to discuss. So those are the things we are going to discuss today. So EV architecture and powertrain. So architecture is nothing but it is the initial phase of your vehicle. Vehicle architecture is nothing but, so when you are designing a vehicle, so when you are making the concept stage, so vehicle architecture is the main, here is the involvement of vehicle architecture. So if you see when you are going to design a vehicle or when you are going to develop a vehicle, the first thing is like vehicle architecture, where all the engineers will sit together, like it's a mechanical or it's an electrical, and all the engineers, even the design engineers, they will sit together and they will make a concept. So the electrical guy, the mechanical guy don't know what is the motor specification and all the things. So here what we are going to do is we are seeing what is the involvement, what are the things the vehicle architecture will be doing, how the architecture team will work, collaborate related to electrical and mechanical, all those things we are going to see. So if you see, we have 4 steps of the vehicle process from the conceptual stage to manufacturing stage. So in the conceptual stage, here the concept will be released. So either we are going for here I will be taking an example of an SUV or like a MUV. Like we can see when you want to design a vehicle, so they will see the market, like which vehicle they want to launch. See, here in automotive industry, everything has been done. Like see, if you want to launch any vehicle, we have an SUVs are there, we have an MUVs are there, we have the small two wheelers are there. So all we have the benchmarks of the vehicle. So they will decide they are going to launch SUV or sedan or which kind of the vehicle they want to launch. Based on that, the conceptual stage will be starting. So they will come with a rough layout. So there, from there, the concept after designing the vehicle architecture, which is nothing but you can see the system engineer. So the system engineer, what he will be doing is he has the knowledge of all the vehicle. Like it can be a brakes, it can be a suspension, it can be a steering, it can be a chassis, it can be a powertrain. So they will develop a 1D simulation. They will be doing the 1D simulation and they will be knowing the requirement of the vehicle. So there the requirement of the vehicle and they will come with a rough layout. So how the vehicle should be there and what is your overall final performance you are targeting and which kind of software and hardware we are using, what is the timelines. So these are all the things overall layout you can be doing in the second. After that, the step 3 you can see here directly the detail view, like you will be getting the CAD model. You are going to develop a CAD model of your vehicle and you will be doing system level simulations and all the things. After that, the prototype development, manufacture, like developing the prototypes and going to homologation testing and later we will go for the manufacturing. So the vehicle integration person, he can see the whole vehicle from step 1 to step 4. So in the same way, so that is the evolution of like vehicle architecture. So vehicle architecture is a very important role plays in the automotive industry or like the person who is doing the vehicle architecture. So here we have a silent revolution is transforming automotive. So if you can see from 1990s to still to like 2022. So there is a lot many transition was there in the automotive industry. Like previously we have very bulgy cars. Now we have coming optimizing the small things and we are coming everything automated. From the car we are going everything is automated. Like we can operate through the smartphone. So these all are like the architecture. So development of an architecture. So coming to the EV powertrain architecture. So previously we have discussed how the whole vehicle architecture. So now we will see just what is the thing is currently what all the industries, even if you see Tata or Maruti or Hyundai or like Mahindra, any company, what they are trying to do is they are trying to convert their present vehicle to an electric vehicle. Suppose, as I said previously in the starting, we have a Tata Nexon IC engine vehicle. If you see clearly, the Tata Nexon IC and EV are both are same. Just they change their powertrain system by keeping the motor, right? So you can see here, I will just show you some. Yeah, you can see the highlighter. So in the highlighter, you can see this is an IC engine and this is a motor. So what the Tata Nexon has done is just they have shifted their engine space, whatever space they have kept for the engine, they have directly kept at the motor. But the vehicle was same. You can see the specific like the what is the wheelbase, what is the track width, and what is your distance between seating, and every position of your interior. Everything is same. The only thing it is changed is the architecture of the powertrain. So the same when we are going to now from the now what we are doing, like if you see Mahindra XUV 700 or like XUV 500, so many vehicles what they will do is they will go for the long term. If you are going to launch any other new variant in the same model, so they will think to just change the drivetrain. They don't want to invest more money on R&D of the interiors or your seating system or your they will come with some new optimization techniques and all the things. They don't need to do any other new suspension system. Nowadays all the automotive industry is coming towards fully software development. They want to automate their vehicle. So that's why EV architecture, when we are designing the electric vehicle, they will see what is the mainly they will focus on the how your high voltage system is working. So previously you can see how your I will think how your steering power steering is working, how your wipers are working, how your vehicle is getting power source like lights, or how your horn is working, and so many electric gadgets like in your even in your mobile charger you can charge. So what is the power source there? There we have the battery and we have the alternator. You can see here we have the IC engine. In the IC engine we have the alternator and we have the AC compressor, and so here the power source is from the engine. So alternator it will give the power supply. Here you can see these are the power supply. In IC engine the AC will work through the compressor. But in the electric vehicle there is a different strategy. So these all are comes under powertrain architecture. So we are going to see detail. So when you are going to shift your IC engine vehicle to electric drivetrain, what are the subsystems are affecting when you change it for the IC engine to electric drivetrain? So if you see the subsystems existing in such an air conditioned systems like electric steering, seat controls, anchor brake, airbags, wipers, headlights, USB charging ports, etc. So these all are low power supplies. Like these all require very less power, so that's why we whatever the power we are getting from the battery or like alternator, we are using that power supply to control all these conditions. But what about when you come for the electric drivetrain? For IC engines, these all the things are IC engine. We have an alternator, and these all the things to generate small low voltage of power supply. But when coming to the electric vehicle, what is the solution? So here, what we will do is we have a DC converter which will convert high voltage to low voltage system. So you can see the low voltage electric supply of the subsystems is obtained by using alternator. Okay. So in IC engines we have an alternator, as I said, which is coupled to engine, okay, from a suitable battery. So new designs needs to be considered demanding the existing architecture and challenges. So when you are going for the here we don't have any alternator when we are using the motor. Okay, so basically how your alternator is going to work, it is attached to the pulley of your engine. So based on that your alternator is going to generate the power. But coming to the electric vehicle, we don't have any outsourced pulley or we will not use any alternator. The only power source. Here we are getting the energy from the battery. So if you want any energy from the battery, you can using DC converters, we need to take the power source from the battery. See, thus from OEM point of view, vehicle architectures needs more flexible enough in adapting drivetrain electrically quickly using existing platforms. So, if you see all the, as I said, we no need to do more research on suspension, we no need to do more research on your seating system or your door panels or your VAW components. The only one thing is how you want to transmit your power source from the rear to front, like how you are going to do all this, how you are going to change your floorboard. Suppose if you see how you are going to mount your batteries, how you are going to keep all your floorboard panels, how you are going to connect your wiring harness and all the things. These are all the things you need to check it. So this is the one of the most important thing. While designing vehicle architecture is responsible for the whole. So vehicle architecture team is responsible for the whole electrification of your vehicle. So when the team, suppose you are a vehicle architecture team, he is responsible for how your vehicle transmitting the whole power from the motor or from the drivetrain. So what are the power delivery paths, like how the power is getting from lights and how the power is getting towards rear view, and how the power is getting from your steering motors and all the things, the cooling system or in the brakes, when we are using regenerative system, how these all the things will comes under electric vehicle architecture and the vehicle architecture team. So they have to follow this. So the electrical powers like subsystems, like when you are using the power windows or air conditions, so these all are very plays important key role in the electric drivetrains. Okay. So coming to the charging system, how your charging system and where is your battery location. So as I said, when we are going to launch any new model, like we have a Creta, So for every year they will come with some new updated version, or like if you see Swift Desire or any car. So when they are modeling the car, they will do in a such a way that they are going to launch any other models with the same electric drivetrain, or like they will see there should not be a must when you are going to launch any new model. So what they will see is like your car is there and your powertrain system is there. If you want to make any changes, they will go with the low budget stage. Like they might be change the motor specifications, like small minute designs only they will try to change, but the overall vehicle will be look same. Or maybe some body panels will be changing. So in such a way that they will design the drivetrain and they will design the harness mounting and all the things. And coming to the your modes, like if you see the electric vehicle has the fully, it is controlled by the your vehicle control unit. So the control systems also plays a major role in EV architecture. So technical specifications, like it will charge, how the charging will be there, and how your vehicle control unit is going to work, and these kind of the things we are going to check it. So interaction with external world. So one side we have seen how the motor is running. See, there is a small example for the IC engines and electric vehicles. If an IC engine stops, there are lot many ways to start your engine. Like you can push your vehicle, or like you can do some things to start your vehicle. Like if coming to the two-wheeler, you can remove the spark plug and you can clean it and you can do it. So many things can be done by the without any requirement. Like you can push the vehicle, as I said, or you can do any some alternative techniques to start the vehicle. There are a lot many alternative techniques to start the vehicle. But coming to the electric vehicle, there is that kind of
Jump start is a way to start the vehicle if battery is drained in the series.
hello. Yeah, sorry guys, like this small introduction. So as I said, we have an IC engine and electric vehicles. So when we want to start the IC engine, there are lot many changes, lot many ways to start your vehicle. But coming to the electric vehicle, everything is controlled by your control system or a controller. So here there is no other alternative source. Like if you push or if you do anything, there is no source of to start your engine, your motor. The only main source is your control system and vehicle control unit. So you have to make sure that the software will also plays an equal role when coming to the EV architecture, and when we in the electric vehicles. It's not like an IC engine. In the IC engine, there are, as I said, there are lot many ways to start your engine. But coming to the electric vehicle, it is very important that your control systems and the way the wiring harness is also plays a very important role, and your drivetrain modules and your control system, this all plays the very important role in the electric vehicles. Okay, so the cost reliable, like safety related parameters, and the communication system, like coming to the electric vehicles, everything is comes under CAN communication. Like you might listen that how the ECU and VCU will be working, so how the control systems are going to work. So these are all the things plays a very important role in the EV architecture. So, as I said, VCU is very predominant and compared to IC engines. In the IC engines, we have the sensors. Like if you see, we have the engine control unit module was there. In the engine control unit module, we will know the position sensors and the temperature and these kind of the things. But coming to the electric vehicles, we know like at which mode we want to travel, like you want to go in the sports mode or you want to go in the normal mode or economy mode. So these all are controlled by your vehicle. Even if you want to go by reverse, this will be converted by in your vehicle. In your ECU will give a signal to the vehicle to go forward or to go backward. So that's way, like in electrical architecture, VCU also plays a very important role. And in India or like in the world, like very less companies will be, every company will be outsourcing their VCUs and these kind of the things. Like if you see some of the like Bosch, Michelin, some companies are there, so they are more working on the control systems like vehicle control modules and all the things. Okay, even if you see the controllers, so many of the companies, like even if you see the Tata or like even any EV companies like which are highly came with their electric vehicles, Mahindra or like you can see Hyundai, what they are starting, they have outsourcing the components. Like they are not going to do R&D. They are doing R&D for another, like after 5 to 6 years they are going to launch that. But currently what they are doing, they are directly outsourcing their way, outsourcing their product, like whether your VCU or your ECU, all these are outsourced. So these VCU must plays a very important role. Like if you see, the vehicle will suddenly there. See, as I said, electric vehicle is very dangerous. It is very, why? Because if you see recently, some vehicles are going to reverse mode suddenly. Sometimes it's going to blast. These all the things are due to some miscommunication between VCU and the controller. So there will be some logic, controller logics will be there. So sometimes the logic will not be activated. So due to that, some out of 100 vehicles, one vehicle might be get this kind of issues. But unfortunately, that vehicle will be in the world somewhere. Some person is driving. So that kind of issues, complaints, like so many complaints has been coming in the electric vehicles. Like your vehicle is going reverse, or your vehicle will not respond suddenly. It is going to stop when you are in the traffic. Some kind of things are. So the whole responsible comes under your VC. When it comes to the IC engine, if your vehicle stops suddenly, we are going to check the fuel first of all, whether the fuel is there or not. Okay, so those kind of the things we will be doing. Sometimes we will be doing jump start, so automatically the engine is going to start. But coming to the electric vehicle, if it stops only due to if your charging is less. But so many people will think the vehicle will stop only if you are having less charge. But the VCU is there, so that is the control system. Sometimes it's not work due to, if it is not work also, that time also it will create some issues during the working. So that's why VCU will play more important role in the electric vehicle. So these blocks, like so if you see some cruise control modes are there. Like if you see in some vehicles we have cruise controls. Mostly in the foreign countries we have in the vehicles there will be cruise control, hill hold. These kind of the things are there. So they will do these kind of hill control and cruise control modes, everything in the MATLAB. Like you can see some softwares are there. Like we have Simulink and each company has their separate own tools when they want to go for these kind of things. But MATLAB is a very common tool for all the automotive industry where they will be using all these things. So these are the very important role in the electric vehicle architecture. So just we will recap what is electric vehicle architecture. So in the electric vehicle, what we will be doing is architecture is very important. How you are going to route your motor, your drivetrain system, where you are going to mount the drivetrain system, and how you are going to couple your battery, and how the energy system is transferring, how you are going to mount your charging system, onboard charging system, how you are going to work on your BMS. So these all things works under electric architecture. So if you are an electrical architecture, so he is a very key role in the whole system. Why? Because if you see an IC engine, there are so many members to replace an IC engine vehicle, guys. But if you see currently in the automotive industry, what is the issue is there are very less people who has more awareness of the electric vehicles. So even still, they are coming with some new regulations and new standards. How we have to design the model, how you have to develop, what are the DVP we need to follow when we are going for electric motors, and what are the drive cycles we need to follow for when we are going for the electric motors, and what is your charging system, what is the discharge cycles when we are going for this outside. So there is very key role. The key role plays very important in the electric architecture. Okay, so what we are going to calculate a simple model, like how we are going to see the vehicle performance, like how the vehicle performance parameters we are going to calculate. So here I have a small example of ether energy bike. So powertrain is a crucial component in any vehicle. We also see a small case study of a powertrain we are going to discuss. Okay. So as I said, this is some of the very interesting topic. So how we are going to calculate the motor parameters. So as I said previously, the vehicle thing. So guys, this is very interesting thing. Like in automotive industry, every company will follow this kind of pattern. Suppose, as I said, if I want to launch any vehicle for next 5 years, in next 3 years, I want to launch my car in next 3 years. Suppose I am from a company, I am going to launch it 3 years. So the first thing comes under the vehicle architecture team. So they will come with a conceptual design, and they will give some packaging space. So in this space, you have to, in this particular dimensions, you have to bring your motor. They will give these two curves, these two things. Yeah, so they will give this torque, this peak torque, and this power, and they might give the suggestion to use which kind of motor. So these three parameters they will be giving, that's it. Remaining every design, we have to reach their targets, like 26 Newton meter torque, we have to give them using this power. Okay, so these kind of the things done by the motor team. So in the powertrain means it is not only the powertrain. Powertrain comes under motor, transmission, and your control system. So here what is the thing is, motor team will get the chance to these three things you will be getting. What is your torque, what is your power, and which kind of the motor we are going to use. So we have to see whether in the particular space you can design your motor or not. So as I said, right now what is the thing is in the industry, nobody are familiar which kind of motors we have to use, or like we have started. We have so many companies, they have started in-house motor development and all the things. Mostly all the companies like even Tata Nexon, it was outsourced motor, even Ether, it was outsourced motor. So many companies, like so many two-wheelers or three-wheelers, four-wheelers, like whatever the electric vehicles as of now, so many are outsourced motors. So you can see these are the Bosch or Mahle. So as per my knowledge, Ether is using Mahle motors. You can see if you have an electric vehicle, if you have an Ether vehicle, you can see on the motor, you can see the sticker of Mahle. Okay, so they are using Mahle motor. They have not done this was not an in-house motor. They have procured from outside. So when you are procuring from outside, the same thing, you are going to give the supplier, you want 26 Newton meter torque and 6 kilowatt peak power, and this is your efficiency curve. So this is your motor torque versus RPM and your motor power versus RPM. These are the curves. This is very, very important. So these are the curves given by as per this curves, you will be getting your speed of your vehicle. What is your control system will be work based on this one. So your torque versus RPM plays a very important role when it comes to your control system. How much acceleration it would need to be done, how much power should be released from the control system. So these are all the things. So you can see in the you can see in the ether, like some videos will be there at 0 to 66 kmph it was going at 3 seconds, 4 seconds, some X time. So these all the things will be given by the controller. So the controller will take how much speed it is coming and how much speed it should send outside. So those all the things will be done by the controller. So motor characteristics. First, you have to come what are the motor characteristics, which motor you are going to form and what you are looking for, 26 Newton meter and what is it. So here we have a small example of how we are going to develop a model in the Simulink. So here I am going to show you the blocks of the Simulink, how we are going to do the Simulink. After this I will share you how we have done in the Simulink. I will be sharing you a link so that you can see the step-by-step procedure. I will be sharing you the module, how we have done the Simulink model. So I will be sharing you that module, but here I am showing you the blocks. What are the blocks I have used, how that is implementing in your drive cycle or in the performance characteristics. So first of all, throttle. So you can see you can see here there is a throttle, right? So throttle is the input of your motor. So throttle input, you can see your, I think so many people has driven, you have seen the electric vehicle, it will be giving in and out. So the throttle input is between 0 to 1. At 1, the vehicle is a full throttle. When you have given full throttle, you can see there will be a straight line, okay? There will be a straight line. You can see the motor torque, okay? The throttle input is between 0 to 1. At 1, the vehicle is so clearly performance and especially the line. It is also known as PID controls. So this all comes under the control system. See, sometimes, as I said, in electric vehicles, you have the throttle itself forward and reverse. If you come to the IC engines or if you see in electric vehicles, there is a chance to go reverse. But if you see in the normal vehicles, there is no chance to go reverse or forward. Reverse direction only, you have to go with the forward direction. If you see some videos, their promotional videos, you can see that ether is going to be in the reverse direction also. If you want to go your vehicle in reverse direction, it will not go max 20 kmph or like 10 kmph. It depends upon the control system guys. They will design their vehicle, it should not go maximum 20 kmph or maximum 10 kmph. So only in the electric vehicles we have a choice to move your motor forward and backward direction. If you see in the Mahindra Trio, so that is an electric vehicle. So that is an electric auto. So it will also go forward and reverse. So if you see in the Delhi, so many e-rickshaws were there. So they will run their motors forward and reverse direction. So why I am telling the throttle, it is very important. Here your controller has an angle. So based on the angle, it will calculate the speed and it will show on your indicator. So here you can see the steady state velocity. So motor power generation. The block output power you can see here. So you can see motor output power here. Motor electrical power. So the block outputs the function of motor RPM and throttle commands. The relation between torque and RPM is set to look up the table and characteristic curve. So you can see that what are the characteristic curve we have. The motor torque is multiplied with throttle. So here, as I said previously, the torque and your throttle is interrelated. How much torque you need to give and how much throttle you need to give. So they both work. Combinedly and they will release the power. So the electrical power output is calculated efficiency motor. So you can see in the efficiency curve, and if you do the hand calculations, we will be considering the efficiency, like how much 80% efficiency, 90% efficiency. So here we have assumed some constant loss of efficiency. And coming to the gearbox, like if you see in the ether, you can see some YouTube videos or some the Google page, you can see the ether has a small gearbox. So we can design the gearbox also. In the Simulink, what we can do is we can export all the blocks from the library. So I will show you that in the upcoming slides, like how you want to export the tire, or like how you want to export the control systems and all the things will be discussed now. So in the vehicle body, as I said, in this vehicle body, we will be having the wheel torque. When you take the wheel, and we have to give the torque, and we have to give the wheel force and the radius. So how we are going to get the torque, wheel torque. So based on that, the block is going to work. So this is the finally, like what is your velocity comparison. The vehicle velocity here, it is converted into 60 into v by d. So into is equal to n. So here you will be getting the velocity of the. So here you can see we have done in the MATLAB simulation. So this is a small block which we have run in the MATLAB. So what we are going to do is we will get the simulation result. Here you can see the line. So this is the simulation result which we have got, and this is the real-time result which we have. So how we are going to compare with the real-time and simulation result? So what is the thing is, real-time results will be measured using some. If you want very accuracy, you have to use CAN tools and all the things to log data logger and all the things, vector tools, data loggers. You have to use that one, and you can take your speed versus time curves and all the things. Or else you can see in the Google Maps itself, when you go with 40 kmph, what is time taken, like all these things. So the second one which I said in the Google Map, it's very like not reliable. But if you want to see your real time result, the only way is like you have to connect your controller. Like if you participated, if you see, we have normal Kelly controllers which they have the Bluetooth and all the things. Through that you can connect your vehicle, and you can see what is the maximum speed at how many seconds it's going to reach the maximum speed and all this. So we have the powertrain architecture. As I said, we are doing the moving lab. There is some disturbance coming. Yeah. So EV powertrain architecture. So here I am going to discuss. So what are the things we can do? Actually, what industries they will do in the MATLAB? Like you can see, as I said, if you want to run your motor for from 5 lakh kilometers, or like 50,000 or 100,000 kilometers, how you are going to run? So many, they will not run the vehicle, and they will not. They will use dynamometers, dynamo, electric dynamometers will be there. They will be test their vehicle in the dynos. So they will give the cycle, IDC. So many of you know that Indian drive cycles. So we have different standards. Like what is IDC is like, they will take certain road as an input reference. They will have some potholes and all the things. They will take that IDC cycle graph, and I can show you that one in the next slide. So they will take that IDC cycle, and they will give it as an input, and they will run the motor. So they will run for like few thousands of kilometers. Based on that, we will know the performance of the motor and all the things. So this one, which is done after the manufacturing phase. But the same thing we can done in the MATLAB Simulink. Like you can load the drive cycle as an input, and you can run your vehicle for some particular time. So you can see here. So yeah, here we have given the drive cycle resource and the controller and the passenger, and you can see the visualization. So you can see in the libraries what are the things you can get: energy, drivetrain, propulsion, and transmission, and vehicle dynamics. So these all are, you can see in your Simulink library if you have a proper license. So in the Simulink you can see all these drivetrain modules. So there you have to load your IDC cycle. What is, you have to give it as an input. So based on that input, you can know the performance characteristics curve. So as I said here, you can trace your velocity, you can trace your motor RPM, you can trace your motor temperature, and you can see your battery SOC. If you are going for the electric hybrid vehicles, you can see the what is the fuel consumptions and all the things. So these are the all things we will be doing all these blockings in the Simulink, so that you can get an idea like how the Simulink background is going to work and how we are going to do in the Simulink using Simulink. So coming to the careers in EV industry, okay. So everyone are very interested. Like mainly the webinar may focus. We will focus on the careers in EV industry. As I said, we have lot many job opportunities right now. There is a huge opening in the market. Like they are hiring even freshers also. The people who has very little background of electric vehicles. If they are worked on little related to electric vehicles or something related to electromagnetics, or you have an idea of electric integration, what we have discussed previously, how your powertrain is integrated, or if you have a background of MATLAB, like if you know the programming languages very well. So we will discuss one by one. What system engineer role? System engineer role plays very crucial role in the whole automotive industry itself. System engineer is nothing but he is the guy who decides the whole vehicle parameters and all the things. So which kind of suspension we are going to use, what is the stiffness, which kind of the brakes, which type of brakes we are going to use, which kind of steering we are going to use, what is your motor characteristics, curves, and all the things they are going to. These all the things were done by the system engineer. So powertrain modeling is nothing but system engineer. He must be aware about 1D simulation. So 1D simulation is nothing but your G suite. Like if you are aware about G suite, there we can do the 1D simulations. So powertrain modeling and application software, like coming to the software. So see here, ECE students, the people who are from ECE background, they can also learn like how your control systems will work, how the, as I said, hill hold is there, how your cruise control mode is there, how your vehicle is going reverse and forward direction, how your vehicle is sensing your battery, charging and SOC. So these all are comes under software development process. And CAD and CAE, these are open for anyone. But coming to CAD, you must be more, it is common for all the things. Coming to CA engineer, there are different kind of motor simulations are there, which are very new for all the CA engineers. So we don't have any reference. So they are developing standard procedures. And electromagnetic simulations, like we have so many electric vehicles right now. Like we have Ola, we have Ether, we have Simple Energy, we have Tata Nexon, we have Mahindra E2O, so many electric vehicles which we have. So, but in all the vehicles, all their motors are outsourced. No company as of now they have done with in-house. Mostly some companies they have came with in-house, but so they are preferring outsource because they don't have particular engineers who are more familiar in electromagnetics, power electronics. Okay, so these are the things very important. Coming to wiring harness is nothing but in electric vehicle, there will be a so much part of your 30%, 40% of the vehicle is covered with wiring systems. So wiring harness is nothing but routing your controls. So that plays very important. And vehicle level testing. So vehicle level testing comes under testings, and electrical integration, which we have discussed, and ECU testing. Control unit and control system modules. So there is a, like you can see, if you have a little scope, if you learn something related to EVs, or like if you worked on your EV projects, so there is a more chance to get the job opportunities in the industry. Yeah, Vikas, are you there?
Hello.
Yeah, Vikas.
Yes.
Yeah, you can continue, Vikas.
Hello.
Hello, Vikas.
Yes.
So can you like I think there is some discussion related to what are the course related to course. Can tell you that.
Okay. So no, like you have done with your PPT or?
Yeah, I have done it like yeah. It has a long just
Yeah, so audience, if you have any queries regarding anything, you can just ask right now.
Hello.
Hello.
Yeah,
Hello.
yeah, Ganesh.
Hello.
Thanks a lot for giving a very good insight in such a short time. Uh, what,
Hello,
in
sir.
your perspective, what is? Yeah,
I'm so sorry for disturbing you in the middle. I just want to ask, can we make a hybrid engine? Like, if we run on the petrol engine as well as on the electric vehicle, it will be more efficient for us. Like, if we have enough fuel for 200 kilometers, it will be like 400 kilometers.
Yeah, like we have the hybrid engines also, like we have hybrid electric vehicles also, which we are ongoing. So you can see, yeah, hybrid vehicles also there. The research is going mostly on the hybrid vehicles. But the why the hybrid vehicles are not coming fast to the picture is they have to integrate both electric and your motor. So that's where the hybrid electric vehicles they are getting little delay in that. So electric vehicles it is very easy to integrate. So that's the reason why electric vehicles are hybrid vehicles are very taking some time to get in the industry.
Okay, so I have seen a video on YouTube in which there is a person who transformed his bike into a electric vehicle as well as on it runs on the petrol engine too. So what he has done that he has transformed his front wheel axis to the electric one. He has placed a motor in the front axle, or you can say at the in the front axle, and the rear axle was connected to the petrol engine only. So it was driving through the both the modes, like on the petrol as well as on the electric mode.
Yeah.
So can't we do this with the car too? If we put the battery in the front side or in the front hatch and the engine on the back side, it will be beneficial, no?
So how you are going to couple, like if you want to stop the vehicle, how you are going to engage and disengage your vehicle?
Like there is a switch. I have seen there is a switch in that motorbike in which he uses that switch for the turning of the engine and turning on the electric motor, and the same goes for the petrol engine too.
Yeah, see, you can, what you said is for the electric hybrid engine, there is a, like as you said in the front as an engine and back, but you have to couple those two powers, like when you are not using one source, how the other source is getting worked or how the other source is getting stopped. So the integration part plays very important role, how you are going to couple both the motors, sorry, both the systems as an IC engine and as an electric motor. So you can do it,
Okay.
but the thing is how you are going to couple both the things.
Sir, will it be beneficial for the only for the two-wheelers, not for the commercial vehicles, or we can say the
See, as
cars?
per my knowledge, two-wheelers are very less for the hybrid. So many are going for the four-wheelers for the hybrid technology as of now, but maybe in the future hybrid may come in the four-wheelers also. Sorry, two-wheeler.
Okay. Okay. So can I ask you one more question?
Yeah, please go ahead.
So I want to know if we run like if we make an hybrid engine which runs on the in petrol as well as on the like electricity also. So if we turn on the engine for petrol purpose, can it be recharged while we drive? Can the electricity or can the battery gets recharged?
Yes,
Or it
yes,
will not?
using regenerator system it can be get recharged.
It can be get recharged, no?
Yes.
Okay, okay. Thank you so much. That was my
Yeah.
doubts.
Uh, thank, thank you, Ganesh, Mr. Ganesh, giving the insight in very little time. One thing what we are in right now, we do have, we are working in the engine controls. So, what exactly you are seeing as a shift or the transient, if it's happening for control guys from power electronics or from the Indian power electronics to the EV power electronics? And second, what are the major challenges for the EV? One or two, if you can explain
So,
it.
yeah,
And
what are the major challenges from my point of view is your control systems. As I said, clearly, like in the IC engines, there is no very less chance of your control systems. Like we will be using the sensor based was very less in your IC engines. Like maybe your sensor is not work also, your vehicle can run. But coming to electric vehicle, the whole vehicle is controlled by your control systems. Like even if your vehicle stops as I discussed. So in coming to the electric vehicle, the power electronics and the control system modules like these will play more important role. Like whether if your vehicle want to stop sometimes, some so many will think if we release the throttle, the vehicle will stop. Sometimes it may struck so due to some improper logic or some mismatch of the signals. So these kind of the things plays very important role in your control systems and your controls.
just adding to the point, we can have the redundancy of it. If one thing is falling short, then other thing can be into the picture, the other control systems. So this is the way in the for the IC engines also in the European countries, we do have the two controllers. If one is
Okay.
getting some bad part of it, then another controller will take care of it. So by that logic, whether EV industry is heading to, it's used
Maybe
to have
like
the lot.
as of now, like no company they are using two controllers. Maybe they are using the logic. If one will not work, maybe other will chance to get activate. But as of now, this not game. Like if you see recently, small issue has happened with Ola. With they have gone the
Yeah.
river. So many will be telling that is due to motor problem or it is due to controller. But still now we have so many not found the root cause analysis. Like is it so many will think that the control system is not working. Sometimes we can think that the hall sensor which is in the motor it not given the proper signal. So we don't know that one which is a part of the reason. So here as you said if we have two controllers, so integrating the both of them and taking the signal, still we need to do. See, as I said, EV industry is very new to all the Indians, maybe in the outside world also. So that's where
Yeah.
still the research was going on. So we can't tell like we can't use two controllers. Maybe the alternatives can work on it.
Okay. So it's still under discussion or
Yes.
under review
Yes.
as the case is.
Yeah.
Okay. And major challenges what you see in front of one or two as a control engineer or the control system integrator in the IC engines, we are already in for the 15 to 20 years. Now, if we want to shift, we do have some companies called, but exactly what to pick and when to pick, what one or 2 point you can suggest to us?
It is you are asking related to control systems or power train and this one like motors.
Uh, yeah. We are already into the controls for the IC engines.
Okay.
So if we
So
want to have a jump, so exactly which way we have to focus on?
if you want to go for this one, like you can see the you can go for the CAN communication. This one is the right. So how the communication is happening between your control systems. So you want to work on the controllers, like how the PGU, these controllers are going to work. How the see, like even as I said, the control system, the whole controller is made in China. As of now, like what see, even we also like how your vehicle, like as I said, hill hold is there, cruise control mode is there. So you must be aware of this kind of how these logics are working. So you can look to some
Correct,
case
correct.
studies.
Yeah.
You can go
See,
through
getting
some
it converted, correct. We are using with IC engines communicating to the ESP, and then these features are getting realized. And by the standalone also with the Indian help, we can realize these features. with some changes into the vehicle electronics. But what my question is, how challenging is doing in the EV with respect to IC engines? This is what my question is.
How challenging I see with respect to EV means, and I was not getting exact question.
The power consumption or the power changes, what is happening if I'm going for the step size for the cruise control from a certain speed, I am going to a 5 or 10 or this. So we can have a smooth transition in EV. So exactly how to map those case studies, that is what I was looking for.
You said cruise control or something like your voice small disturb in the middle. Like I broken something like a small thing you have missed.
Okay.
Can you? Yeah, tell me once again.
Like cruise control, we do have a set engine parameters under which it will work with the vehicle speed, under which in the this gear condition or the gear condition it will go for.
Yes,
So
yes.
EV, does it has the limitation, means
Yeah.
giving a step size of 5, 10 or something like that,
Yes,
and
yes.
coming out
Yeah.
of it.
Yeah, yeah.
Yeah,
So
that is
I,
what.
yeah, in the EV also we have the controller. So if you have a throttle, like you can, I will show you small demo of the Ola scooty. You can see, right? Have you gone through the Ola scooty, like how the cruise control mode was there? So when you
No.
when you are in the highways, when you are going for the highway for the long stretch of 10 kilometers highway was there. When you want to travel in that highway, you can activate your cruise control mode with keeping 50 kmph, and you can go it. When you want to deactivate your cruise control, just rotate your throttle. So the signaling process will be done by your control system. But still here, the problem is with whether your throttle is responding properly or not. As I said, your throttle angle plays very important role in the cruise control mode. So when you are activating your cruise control, sometimes one issue what I see is when we are activated cruise control, it was going directly 50 kmph, it was not coming backward. So this all comes under your signaling issues. So
Correct.
the controller, yeah, tell me something else.
You are perfectly correct. If I am releasing the throttle, it is not coming back to its original position. So the
Yes.
signal what is reaching up to the ECU, if it is not getting proper, then there will be an issue. It can be pointed out on the controls.
Yes, exactly. So this is the things what we are facing in the present vehicle. So present, this is the some of the one of the issue what I have seen recently.
Right.
Yeah.
It's really nice, and we want to be in touch with you so that we can have an insight more in this.
Sure, definitely.
That's it from my side.
Yeah. Okay. Thank you.
Thank you. Thanks a lot.
Any more questions?
Hello. Can you hear me? Yes, sir. I am a member of a Formula student team, and we are planning to shift to the EVs next year.
Okay.
So I want to module Powertrain Simulink. So can you tell me what are the basics should I know for the moduling?
So basic powertrain modules in the sense you must know the basics of Simulink first of all. So how to control your how to use the parameters in the Simulink. So like how to import the vehicle, how to import the tires, and how to import the motor. So see, for a formula vehicle and all the things you know to drive your IDC control and all the things. You can see your basic parameters like what is the velocity you are reaching, what is your SOC and all the things. So what I previously was told is that for when you are going for the standard vehicles, that time you have to check for IDC, drivetrains and all the things. But coming to the formula vehicles and all the things, you don't want to go for IDC because you are going in a full stretch road or like there is a normal road. So you don't want to go for IDC range and all the things. So it is very simple when you are going for this kind of Simulink. So as I said, you can view the throttle as an input, and there you can view some curve which you want to run your. I think you can get it from the note where you can see how the formula. If you see DIC circuit, you can see some inputs. You can get it. So through that you can model in the Simulink. Even though I will be sharing you one template how you can run your vehicle modules and all.
Okay, so thanks so much.
Yeah. Any more questions? I think because you can continue.
One last question, just
Yeah, tell me.
one thing, three parameters: motor versus the torque, and motor versus the kilowatt hours versus the RPM. These three parameters will be given by the manufacturer.
Yes,
Then
yes. Not
how the
manufacturer, but the vehicle integration thing. Sorry, architecture thing.
yeah, yeah. So exactly what challenges do they exactly face? Because this is being outsourced, as you are very well saying. All the major companies have outsourced this to the tier one or tier two suppliers. So
Yes.
getting it properly done is a challenge. So what exactly they look for? Which test cases?
So, see, what we will be doing is, as I said, suppose take an example of an ether. So they have the full vehicle module. So they know where the motor is going to mount, where your battery is going to mount, and all the things. So they will give some to the supplier like they will call all the suppliers and they will give those parameters like RPM and all the things. So they will ask whether you can reach the limits with the same spire, with the same distance, and whether you can get the same graph which I have shown you. Okay, so if they show like if they can achieve, they will take some time to design and they will give the rough layout. Like they will see thermally and they will see the material cost and they will see all the parameters. Based on that, they will come up with whether we can accommodate in that space or not. Whatever the space given by vehicle architecture team, whether they can accommodate or not. If they can't accommodate, there is a small changes. See, the vehicle still release, there are lot many changes in the vehicle. Even though after release also they will change for few vehicles. So we can't directly tell that first the concept is designed, after that it's going to the full stretch. If some issues get when there is a manufacturing process, again they will change the vehicle design. So we can't directly depend on the dimensions what we have got initially. So still the vehicle is going, even though if the vehicle is launched, some issues has got in the motor. So they will see root cause analysis. They will do the root cause analysis and they will try to change the motor dimensions, or they will try to change the motor position, or like they will see what are the parameters we can do. So those kind of the things are done. So they will talk with the supplier whether there is a possibilities, any alternatives can be done or not.
Exactly the same way what we are doing for the right now, how the industry is doing for the icing the controls.
Yes, yes.
Okay, okay. Done.
Yeah. Yeah.
Thanks.
Okay, thank you everyone. I hope all the queries has been resolved. Uh, so thank you everyone for joining with us today for the webinar on EV powertrain architecture and modeling using Simulink. Thank you Ganesh sir for your valuable time and a short overview on powertrain architecture and Simulink. So we hope all you have got to know about the various things of EV powertrain and architecture. So this was the first module from our 6 months professional master certification program, which is designed by various automotive industry experts, and it is certified by Automotive Skill Development Council and supported by Society of Manufacturers of Electric Vehicle.